So welcome back. We'll be talking about TCP/IP. TCP/IP. So I want you to take note that my explanation on this TCP/IP will be built on our previous explanation on OSI layer model. So if you don't really understand OSI layer model, I want you to go back to that lecture and watch it over and over again. If you have questions, send your question to me so that you can better understand this TCP/IP part. So now, TCP/IP is just a condensed version or condensed model of OSI layer. Okay, so we said OSI layer, quickly recap. OSI layer is just the step-by-step process that communication between two systems follows, right? So now, and this step-by-step is in 7 layers. 7 layers. Oh, here are the 7 layers. Okay, here are the 7 layers. So now, this is OSI layer, right? So now, instead of having 7 layers, we now say, network experts now say, let these 3 layers be condensed. Let transport remain. Let network remain, but it will be called another name. And let's condense this data link layer and physical layer. Okay? But this OSI layer is still the foundation of everybody. Okay? So now, the 3 top layers, 7, 6, and 5, is now being condensed, and it is called, they call it application layer. The three top layer, layer 7, 6, and 5 is condensed, and it is called compressed. They compress it and give it one name, and they call it application layer. So transport layer remain transport layer. Transport layer. Network layer, they call it internet layer. They still perform the same function. They still perform the same function but different name. And data link layer and physical layer are being compressed and called network access layer. So instead of 7 layers in OSI model, in TCP/IP, so this is a TCP/IP model or layer model. So instead of 7 layers under OSI layer model, we have just 4. Okay, we have just 4. This is 4, this is 3, this is 2, this is 1. We have just 4 layers. Okay, so whenever you see TCP/IP, this is the layer they are referring to. Whenever you see TCP/IP layer model, this is what they are referring to. That is why I said you should understand OSI layer model very well before you come to the TCP/IP model. Okay, let's talk about TCP and UDP. So now, application can either be TCP based or UDP based. TCP based or UDP based. I told you that protocol do represent applications. We have different protocols. Okay, we have different protocols. For instance, HTTP protocol stands for web. Anything web service. Okay, anything www dot whatever service. Okay, FTP is for file transfer, right? If you are sending file between two systems or between two phones, between two handsets that are making use of IP. Okay, by the way, your phone as well are making use of IP address, but you don't take note. You didn't take note. So FTP is for file transfer. Okay, file transfer service. Okay, so application render service, and this service are being represented by protocol, by systems. So now, from our explanation during OSI layer model, when these services get to the transport layer, this is where we normally pick up their port number. Okay, each protocol has port number, right? If you remember, port number is what differentiates between these applications on the host, whether on the sender side or on the receiver side. But most time it is at the receiver side. Okay, so we have what is called port number. So now every protocol coming down the stack, whenever I say stack, this is what I mean by stack. This is a stack coming down the stack like this. Okay, this is a stack, OSI layer stack, 7-layer stack. So any protocol coming down the stack, when it gets to the application layer, that protocol can either be TCP or UDP. Okay, meaning application can either be TCP or UDP. TCP or UDP. So now, every application coming down will fall under these two categories. Okay, based on their nature. It is people that design this application that know the reason why they make this application TCP, why they made the other UDP. But let me explain what TCP and UDP are all about. So now, TCP applications, they follow what is called three-hand shake. Three-hand shake. You can jot this down. TCP, they follow what is called three-hand shake. Hand shake. Okay, and they are reliable. They are connection oriented. Let me explain what they mean by this. When you agree with me that in every network established, we always have a sender, somebody sending message or sending data, and we always have a receiver, right? Okay, let's say this is a sender. Okay, this is a system sender. This is the receiver. This is the receiver, right? So now, TCP IP applications, before they can send a TCP-based data or a TCP-based message, they need to establish connection. Okay. So before the sender send any message to the receiver, it will send what we call sync packets by asking, hello, sender, are you available to receive a message? Okay. The sender will reply, yes, I'm available. Okay. The sender will now send the data. Okay. This is the message. Receiver will acknowledge. You send, thank you, I have received the message. So this process of sending message between the sender and the receiver is what is called three-way handshake. Three-way handshake. Three-way handshake. Three-way handshake. Three-way handshake. Okay. This is the first handshake, whereby they synchronize as, I want to send you a message. Are you available to receive it? They both first synchronize. Okay. The second stage, the sender now send the message and the receiver acknowledge it. Okay, and the receiver acknowledge it. So this is the first handshake. You can call this 1. This is first handshake. This is 2. And this is 3. Okay. So it is called three-way handshake. Okay. For every TCP-based application, they always follow this three-way handshake. Okay. Three-way handshake. This is normally used in sending file, sending email, so that there will be no loss in the packets. There will be no loss in the traffic to ensure efficient delivery of the message. That's nothing lost. Everything deliver complete, to avoid incomplete delivery of data. Okay, so any sensitive communication whereby any loss in the data can make the receiver not to understand what is being sent, such application is designed to be TCP based. Okay, this is normally used for file transfer, email. Okay, so that is it. So now let's explain what UDP is. Now we have UDP. UDP is just opposite of TCP. So UDP is opposite. UDP doesn't check whether the sender is even alive or not, whether it is receiving or not. It's just send. Okay, doesn't check whether the receiver received the message or not. Just send. Just be sending, send. Just be sending message, sending data. So it's just sending. It doesn't even check whether it deliver or not. Just send. If the receiver also need to send anything back, we just send it back. If the sender wants to, they are just sending without even acknowledging whether the message gets to the receiver or not, whether the message gets to its destination safely or not. Okay, that is what TCP does not do. TCP will check whether the packet gets delivered to the destination or not. And if it doesn't get delivered to the destination, the receiver will ask the sender to resend. Okay, if there is any loss. Okay, if the receiver doesn't receive the packet completely, it will send a signal back to the sender to resend that data, that particular part. But in the UDP, in the scenario of UDP, whether the packet delivered or not, it doesn't matter. Okay, example of this is all these voice and video based applications. That's why sometimes when you are watching movie, okay, or when you are watching movie online, maybe live transmission, when the video is breaking, that part is gone. Maybe network was bad, you couldn't hear particular part, or you are watching football. Maybe at the point network was bad, the motion was skipping. So the picture was skipping. You couldn't get that part very well. That application doesn't care. It continues transmitting. So that part is gone. It will continue with the next part. So this is commonly used in all these voice and video based video based application. Okay, that's like when you are talking on the WhatsApp and you will just be talking to the ear, whether the other end is receiving it or not. Nobody cares. The application doesn't care. Okay, so that is the application of UDP. UDP. So an application can either be UDP or can be TCP based, okay? But what UDP is mostly used for is what I just explained, and what TCP is mostly used for is for this email web traffic too. That's why when you are trying to reach a web server, you can easily reload your browser and it will still bring the page you are trying to load. But live transmission of a music, video, once it is gone, it is gone, okay? Nothing like checking for acknowledgement to see whether that data gets to the destination or not. Okay, so when they mention any application, any protocol, any application layer protocol, that protocol will fall under TCP or UDP. Okay, you can read more about which application is UDP based, which application is UDP based, and which one is a TCP based. So anything that has to do with file transfer, like file transfer, okay, file transfer, okay, that is making use of FTP service. FTP protocol is we have a web service. All these are TCP based. Web service. We have SMTP for email. Okay, HTTP for web, SMTP for email, SMTP. All these are examples of TCP based application, because in these aspects, users don't joke with delivery. Okay, when you send an email to somebody, it must deliver completely. But when you are having a video call with somebody, if at a point there was no network, you can later catch up once the network comes back. So with that, you can easily understand what the other person is talking about, or the other person can repeat itself whilst the network was still is still up and running. Okay, so anything foils video app, okay, anything video conferencing app, they fall under UDP. Okay, like Zoom application, Skype application, okay, all these online streaming movie application. Okay, when you are streaming movie online. So all these applications are UDP based. Okay, and also I think one of the reasons why they are UDP based, whereby error checking is not done, they say the way it is done in TCP. I think one of the reasons is that it will be very fast. Okay, instead of still asking, have you received the message before you can send another one? While watching a video, there is no, as in, there won't be no, that delay will not be there. There is no time for that delay. Okay, when you are streaming video, I mean, the video or music need to be streaming smoothly. Okay, without the application skipping or delaying and all of that before it can transmit to you your video or your music. So this one is very fast. It's faster. Let's say this one is fast, but UDP is faster. Okay, any application that is UDP based is faster. Okay, and this one is reliable. They said is reliable because there used to be no packet loss and all of that. Okay, if the sender has not acknowledged that it received that particular packet, the sender will not send another one. Okay, unlike UDP that keep on sending without even caring whether you the spectator or you that is watching the movie, whether you were able to whether you're able to see a particular scene or not. Okay, so let's move to port number. Let's go and discuss port number. So now, from my explanation so far, I said port number are used at the transport layer to differentiate between which application is using which service. Okay, let's go back to our layers. That's why I said you should understand this very well. You have presentation layer, you have the session layer, here we have transport layer. Okay, so let's say we are dealing with FTP service. FTP, that means two systems are transferring file to each other, maybe through Bluetooth. Okay, so now this is the sender and this is the receiver. That's the receiver. So now, when that file gets to this layer, okay, you need to append, you need to add the port number information. Okay, every protocol has a port number representation at the transport layer, and that can either fall under TCP or UDP. Okay, that is why major protocol under this transport layer is a TCP and UDP. Okay, so for instance, FTP is a TCP-based protocol. So the port number is 21. The port number is 21. Okay, so this sender will attach to that data that the destination port number of this message is 21. When you get to the receiver's end, tell the receiver that this message has port number of 21, so that when you get to the application layer on the receiver end, the application layer will be able to know that it is a file. It is a file transfer protocol. It is an FTP. Okay, it is a file maybe for music, maybe for video or whatever. So now, let's talk about port number. So port number, every system has 16 bits to use as their port number, whether they are sending out or whether they are receiving. That's what they will use to know what an application stands for, what a service stands for, what a traffic stands for, what a message stands for. They have 16 bits to play around with. That is 2 raised to power 16. Okay, this is around 65,000. Around 65, I think 65560 or so. Okay, so this is the port number to play with. Now, at the Network Research Center, they dedicate 0 to 1023 to well-known services like HTTP web service, like DNS service, like FTP service, like SMTP service for email. So it is dedicated for known services. So we call it well-known port number. So it is called well-known port number. Any port number that falls in between 0 to 1023, they are well-known port number. Okay, they are well-known ports number. For instance, HTTP is using 80 and 443, depending on which one you are using. FTP is using 21. SMTP, FTP is using 21. Is a very well-known for file transfer. We have SMTP. It's also well-known for email. This is for email. it has port 25. We have another one called DNS. Okay, I will still explain DNS later. This is another well-known. It has port 53. Okay, these are well-known. We have one called Telnet. These are well-known port number. These are well-known port number. So now, whenever a sender wants to send to receiver, okay, maybe you are trying to go to facebook.com. Facebook.com, this is the server. Okay, you are the sender, you are the one trying to go to Facebook from your system. So now this facebook.com will leverage web service which falls under HTTP protocol. HTTP protocol, okay, which is a port 80 or 443. I explained this earlier on that 80 is not encrypted, it is in plain text, while 443 is in encrypted format, okay, or 443. That's the port number of anything HTTP traffic, okay, HTTP traffic. Okay, let's say it is encrypted. Encrypted is always written as a HTTPS. So the port number is 443. Okay, so the sender will automatically generate a port number just to identify itself that it is the sender of the traffic. Okay, so we can say its port number, it is automatic 5050, for instance. Okay, this is the source port number, meaning the system that is sending the traffic, its port number is 5000, while destination port is 443. Okay, the Facebook server in this regard. So now, if you notice, the source port number is 5000. That means already above the well-known port number, because it is just there to signify that this is the host that is sending traffic to Facebook. That's all. Once this session is terminated, once you close your browser, once you clear your cache, it will delete this port number. If you delete it, okay, if you try to go to Facebook again, another port number will automatically generated. This time around, it can generate, next time you are going to Facebook, it can generate something 7,000. Okay, but anything in between 0 to 113, they will not touch it because they are for well-known services like web, like DNS, different services. Okay, so you can read more. You can read more about this port number and the application layer protocol to understand better how this thing works. Okay, but just take note that it's not a must that you climb. Just know the popular services, the popular application protocol, and their port number. Okay, HTTPS 443, that's the port number. Telnet is 22 or so. This is 53. This one is SMTP is 25. Okay, we have another protocol for email too. We call it POP3. POP3 is 1110. Post office post email protocol is also for email. Okay, so just read more about this to understand better. So what I want you to understand is anything outside 0 to 1023 they are the port number dynamically or automatically generated by senders. Okay, when they are sending message on the network, I'm the one sending this message, so that when Facebook is replying, okay, when Facebook is replying, it will be easier to identify who sent that message. For instance, when Facebook is replying this guy, okay, the destination port, when it gets to the transport layer, the destination port number will be, can you guess? Will be this 7070. Okay? Will be 7070. While the source port will be 443. Okay? Meaning Facebook is the sender in that regard, is the one sending back a response to the sender. Will be 443. Okay, so that when this message gets to the sender and it gets to transport layer, they'll be able to know that, okay, this message is for us. I once generated this 7070 port number, so it is for me, so they can continue to push the message. Okay, the sender can easily receive the message and be okay. Okay, so that's the purpose of a port number.